What do you mean by the term time variant and time invariant control systems? Well, my name is Rishi Remju and welcome to the Backbench Engineering Community, where I make engineering easy for you. So let us ask ourselves that obvious question. What do you actually mean by the term time variant and time invariant control systems? Well, let's find out. So let us consider a particular control system like this. So this is a particular control system. And now when we give a particular input to this particular control system, say x of t, we would get an output over here which is y of t. And this output y of t is somehow related to x of t. That is, y of t is some kind of a function or some kind of a transform of x of t. So we know this, that is, as x of t changes, y of t also changes. Y of t is dependent on x of t, but y of t is dependent on x of t by some kind of a characteristics of this particular control system. So therefore y of t can be equal to x squared of t, or 2 into x of t, or x squared of t plus x of t. So there might be some kind of a relation between this y of t and x of t. So that relation is the characteristics of this particular control system. So therefore by observing this characteristic we can know whether this particular control system is a time variant or a time invariant control system. So what we mean by that is that if this particular control system changes the property with time, then it is said to be a time variant control system. That is, as the time advances, if this particular y of t changes with time, then it is a time variant control system. And if it does not vary with time, that is simply what you refer to as a time invariant control system. But how do we check whether a particular control system is a time variant control system or a time invariant control system? For that, we have to carry forth two steps. The first one is that we have to delay the value of this x of t by k units. That is, wherever we have x of t inside this x of t must be delayed by k units. And now next we have to replace wherever we have t with t minus k. So after replacing t by t minus k, if these two are equal, then it is time invariant. That is, it does not vary with time. But if these two are not equal, then we say that it is a time variant system. So if 1 is equal to 2, it is time invariant, and if 1 is not equal to 2, it is time variant. So this thus is how we check whether a particular system is a time variant or a time invariant system. So now let us see a few basic examples of a control system that are both time variant and time invariant in nature. So by seeing these examples, you guys will have a clear idea of how you can check whether a particular control system is time variant or time invariant. So the first basic example is y of t is equal to t into x of t. So let us check this particular example. So here the first thing we have to do is that we have to delay x of t by k units. So here x of t is delayed by k units. So here we will get y of t is equal to t into x of t is delayed by k units. So therefore we get x of t minus k, because x of t is delayed by k units. Next, what we have to do is that the next step is wherever we have t, we have to replace it by t minus k. So here this can be written as y of t comma k. And now here the next one, we have to replace wherever we have t by t minus k. So now where we have to replace t by t minus k, here in this particular equation we have y of t, which is y of t minus k is equal to t minus k into x of t minus k. So therefore here what we observe is that equation 1 is not equal to equation 2, because in equation 1 here it is t, but in the case of equation 2 it is t minus k. Therefore, it is a time variant system. That is, it varies with time. It is not equal. Equation 1 is not equal to equation 2. Therefore, this is a time variant system. So, let's see a bit more complex question. So, let's take the question y of t is equal to x of t plus 5 plus x squared of t. First one, wherever we have x of t, we have to delay it by k units. So therefore y of t comma k is equal to x of, here we have t plus 5, but here x of t is denoted by k units. So therefore x of t plus 5 minus k plus x squared of t minus k. So that is what we get when we delay x of t by k units. And now when we replace t by t minus k over here in this equation, what we get is that y of t minus k is equal to x of t minus k plus 5, which is x of t plus 5 minus k, plus here we have x squared of t minus k. So here what we observe is that they both are equal. That is, equation 1 is equal to equation 2. Therefore, it is a time invariant system. It is a time invariant system because here equation 1 is equal to equation 2. Next, let us see a bit more complex question. Say y of n is equal to x of n squared. That is, we are taking discrete. Before we took continuous, that is, we took time. Now let us take a discrete system. So y of n is equal to x of n squared. So here first we have to delay x of n by k units. So here delaying x of n by k units, we would get y of n is equal to x of n squared minus k. That is what we get by delaying x of n by k units. So here x of n is delayed by k units. So we get x of n squared minus k. But now when we replace here, we have to replace n by n minus k. So therefore by replacing n by n minus k, we would get y of n is equal to x of n minus k the whole square. So that is a difference here. So here when we observe this, equation 1 is not equal to equation 2. So here, since equation 1 is not equal to equation 2, it is a time variant system. That is, it varies with time. So now let us see the case when this was rather x squared of n. X squared of n. So in that case, what we observe was that when we delay n by k units, we would get x squared of n minus k. And similarly, when we replace n by n minus k, we would get x squared of n minus k. So here equation 1 is equal to equation 2, therefore it is a time invariant system. So this thus is simply how we check whether a particular control system is a time variant or a time invariant control system. All we have to do is that first we have to delay x of t by k units, and after that we have to replace t by t minus k. They both are equal, then we say that they are time invariant. And if they are not equal, then we say that they are time variant. So as simple as that, guys. This thus is simply how you can check whether a particular control system is a time variant or a time invariant control system. As simple as that, there's nothing more to it. So I hope you guys now have a clear understanding of what you refer to as time variant and time invariant control systems. And if you guys found this video informative, please do hit the like button and join this community by hitting that subscribe button. We'll be discussing about the further topics in the upcoming videos. So stay tuned, stay subscribed, and until next time, I'll see you guys in the next video. Thank you.